Hello everyone, welcome back to MindMatrix YouTube channel. So in this video, again, I will be giving solutions to the questions which were asked in GATE DA sample paper. Okay, so let's carry on. So this is my intro. I hope you already know that. If you don't know, you can just read through it. And yeah, there is yet another update. Tomorrow, which is on 25th of January, we are going to have our first mock test for GATE DA exam. Okay, you can register it for free, and there is a video which will be coming in I button, in which I have announced already that okay, how we are going to have our GATE DA Master Challenge series, in which we will be providing 3 mock tests for GATE DA exam. Okay, you can just go to our website and then register for free. Okay, also operating system for GATE computer science students, whosoever is there, you can just enroll for free in our website. Anshu sir have already started with the batch. Okay, so these are our channels and social media group. Okay, so first one is website. You can just scan and reach our website. Second one is Telegram group, where you can post your doubts, questions, anything. So that's the Telegram QR code we are having. And then there is this WhatsApp channel link, channel QR code. After scanning, you can just reach over there. Okay, you can join our channel, WhatsApp channel. Okay, so let's start with the questions. So I hope we have already solved these questions. If you haven't seen these, you just need to go back and then check out. Okay, we have already seen these questions. So yeah, this is the question we will be starting from now. So what do we have over here? Let's see. Let's solve this question now. So the question says x is a random variable with support -2 to 2. Okay, so basically like x is non-zero within this part and this part. Okay, basically it has a kind of distribution, some kind of distribution is being followed by the whatever distribution function is given to me, and it is told that okay, it has distribution within this range only, or at other places the random variable is 0. Okay, the random variable value is 0 other than this range given. Okay, so the range given is -2 to 2 and 99.5 to 100.5. Okay, so it has some value within this only. The PDF, which is probability density function of x, is such that it is equal to a constant c inside its support. Okay, as mentioned. So within this range, basically where it is supported, random where it is supported, the value for that is a constant value, which is c over here given, and it is 0 outside that. Okay, so I hope you know. If you don't know, I think you should brush up your these kind of concepts. So whenever we have PDF, which is probability density function, okay, let's say something like this, it is written like this. Okay, so always remember the integration over all the range for this thing is going to be 1. Okay, the distribution function, when I just integrate it throughout the range possible, I will always get it at 1. Okay, or there is one more interpretation for that. Whatever is the this, whatever this fx function represents, I can consider it to be a normal y. Okay, let's say any curve y, and I'm saying that within -infinity to infinity, the area under this curve y is going to be 1. The area under this curve is going to be 1. I hope it is clear. Okay, so I'll find the value of CO first, and then we'll think about what exactly needs to be done further. Okay, let's first of all read. So the next step I am looking for is the expected value of x. To find the expected value of x, I need what exactly is c value. Okay, so to find out c, I have to do something over here. So I know, as I mentioned, that integration for PDF from complete range is always 1. So I know, like apart from the range mentioned over here, my density function is going to be 0. Apart from the range mentioned over here, my density function is going to be 0. So I can write it like this: -2 to 2. What is this? We know it is c. So c times of dx plus the other range I'm having is from 99.5 to 100.5. Again, within that range also, the this PDF value is exactly c. So I'm having this. Okay, so what is going to be this? This is very simple. Okay, you can just take out c common, and then like, okay, what is the integration of dx? That's x only. Okay, so you'll be having something like this, minus 2 to 2. And over here again, if I say it is also going to be x, so this would be 99.5 to 100.5. What you'll get? 2 minus minus 2. See, subtraction of 2 and minus 2. It will be 4 plus, this is the subtraction going to be 1. 4 plus 1 times of c. What is this integration equal to? That's 1. So you get c equals 1 by 5. That's one way. The other way you could do, which was a smaller one, is simply, that it is given that the value of this, whatever this function is exactly, that's constant. Okay, and within this range, which range? Minus 2 to, let's say, 2. So I'm having c as the constant value within this. Yes or no? I hope you would agree. And then I'm having again this c value apart from this range, minus 2 to 2 and 99.5 to 100.5. This the PDF value is going to be 0. Okay, so I won't be talking about other, these outside minus 2 comma 2 to 99.5 to 100.5. I won't be talking about the rest of the range. Okay, so what do I have over here? Again, I'm having c value over here. Okay, so c is the height of this, c is the height of this. So overall, as I told you, the integration of y dx, or simply the curve, area under the curve, has to be 1 from minus infinity to infinity. So I can simply see that other than the given range, my y value is always 0. So I need not think about that. I need to just think about these values. What? This part only I need to think about. So what would be the area of this portion? Just tell me. This is going to be what? It is going to be, for this one, this just area of rectangle. The horizontal width of the rectangle is 4, height is this, so it is 4c plus. For this one, the horizontal width is 1, height is c, and the area under this curve has to be 1. So again, we'll get c equals 1 by 5. I hope the point is clear till this point, that what exactly value of c we are getting. Okay, what exactly value of c we are getting over here. That is more important over here. So let's see further. Okay, so now we know c equals 1 by 5. Now it will help me in finding out the expected value of x. Okay, so I'll just erase everything now and see. So I know over here that c equals 1 by 5. Okay, now what is the expected value of x? It is going to be nothing but, I hope you know this again, into x dx. Okay, this is x, basically density function into x, and then you integrate it over the range you are having, basically minus infinity to infinity. And when we know that, okay, this the density function is going to be 0 for the range outside the one mentioned over here, so I won't be thinking about that. So I will be just calculating it within the range we are having only. Okay, so what was effects of this? So if you remember, this is c, this was equal to c, which was 1 by 5 within this given range. So I'll be just writing this thing. Let me just write it again, minus infinity to infinity. Okay, and oh sorry, I should be writing that, because that's not something value of c within minus infinity to infinity. That is only within the given range I have. Okay, so I'll just write minus 2 to 2, then c, because within that the value is c only, then x dx. This x is this one. Okay, the expected value we are going to calculate, plus again cx dx 99.5 to 100.5. I hope you can calculate this thing. This is very easy. This is, just take out c common, and then you'll get is, this is x square by 2. Okay, and then from minus 2 to 2 plus again x square by 2 from 99.5 to 100.5. Okay, so one thing over here, 1 by 2 is 1 by 2, like both, this is common in both the sides. So I'll just write c by 2. We already have the value of c, need not worry. So just tell me x square, so 2 square minus 2 square, so it is going to be 0. 4 minus 4 is 0. Okay, 2 square minus 2 square I'm talking about, so this is going to be 0. Okay, 0 plus, just think about this. Should you really calculate what is 99.5 square? No, because that is like x square over here, so it is going to be 100.5 square minus 99.5 square. So isn't it something like a square minus b square? What is it? A plus b into a minus b. And we know the subtraction of this value is 1, and the addition of this value is 200. Okay, simple. So if I just do 100.5 square minus 99.5 square, that is going to be 200 only. So what is the answer? C was 1 by 5. So 1 by 5 into 2 into 200. What do you get? You'll get 20 as the answer. So expected value of x is 20. Simple. Okay, I hope it is clear. Very simple question. Let's move further. Again, a good question we are having over here. Okay, let's see. So this function is given to me. Function is 1 plus x square. So I hope you know, like, there are multiple ways of solving it. Okay, and I'll tell you like what all you can think about. Okay, what all you can think about. So you already know, like, okay, so because this is the quadratic function, so definitely it is going to have some shape like this. Because it's a quadratic function, it will be having some shape like this. I'm not saying that it will be like this only. Like, it can shift somewhere, it can shift up, down. I'm just telling you that the shape is going to be like this, and I do have the real graph for this function, okay, which I'll show you within a moment. Okay, so we'll be having something like this. Okay, now let's understand what is being asked. So we have some this kind of function which will be kind of parabola only. Okay, so what exactly is the saddle point, maxima, minima, and what exactly is this? Let's just talk about this. So first of all, you need to understand stationary point. I'll just tell you in brief. So stationary points are those points where your f dash x is equal to 0. Okay, where your f dash x equals to 0. Now these can be two type of points. Okay, turning points, or simply should I like called saddle points. Saddle points. Okay, what exactly is a saddle point? Turning point, I guess like, okay, when there is a turn, so it would be either local maxima, local maxima, local minima. You can just write mx, mn, or global maxima, okay, or global minima, something like this. So these would be something like turning points, because either the function will change direction like this from downward to upward, or it will be like this from upward to downward. So these are turning points. So at these point also your f dash x is 0. Okay, the differentiation, the derivative of your function would be 0. Another is a saddle point, which would be something like this. These won't be turning point. So if I say something like this, okay, I had a function like this. Okay, so there would be a point when it was like, it was just straight, such that slope was 0 at that point. So that is going to be a saddle point. Similarly, I can just draw it like this also. So over here also we have a saddle point, okay, where my function is not exactly turning, okay, but my derivative at that point was 0. I hope that is clear. And when we talk about more dimensions, saddle point has some more added attributes and parameters and definition to it, okay, which we won't be discussing over here right now. So right now you can just consider saddle point would be a point when there will be no change in your turning point. Sorry, there will not be a turning point, and turning point would be our maxima or minima points. Okay, something like this. And at both of these maxima, minima, saddle points, your f dash x will be 0. Okay, so I hope this brief idea is clear to you guys. Now I'll just talk about, let's just find out what exactly is going to be f dash x. Let's just find out what exactly is going to be your f dash x. So f dash x is nothing but what? Derivative of 1 is 0, x is 1 plus 2x. Okay, if I put it to be 0, then what do I get? X equals minus 1 by 2, which is 0 0.5, minus of 0 0.5. X equals minus 0 0.5 at f dash x equals 0. Sorry, at x equals minus 0 0.5, your f dash x is 0. So this is wrong, because at this point this was negative over here. Okay, the point was over here, negative was mentioned. So basically f dash x is not equal to 0. This is saying, which is wrong, because we know, we have just found out. So this is wrong. Now, as we know one thing, that okay, like if I just simply understand, I just try to draw this graph, what exactly would it be like? So if you know y equals x square, how do we draw this? Y equals x square is nothing but something like this. Okay, just remember this. These are something very important thing. Okay, especially when you're talking about DA exams now. So y equals x square is something like this. Okay, so if I just solve it in some way, in if I just simply simplify it in a way where I can represent in some kind of a better representation, then I can still plot the graph. But yeah, let's see how can I do it better. So this would be, if like, it is going to be x plus 1 by 2 square plus 3 by 4. Yes or no? If you just simplify it, if you just simply open this up, you'll get this thing only. You'll get this thing only. So what should be the graph for this one? So this was y equals x square. So there is, within this x part, there is x plus 1 by 2. Okay, there is this x plus 1 by 2. So turning point over here was x equals 0. Over here, turning point would be x equals minus 1 by 2. So I know the minima point would be x equals minus 1 by 2. Okay. Now at minima point, what will be the value of y? If I just put x equals minus 1 by 2, what will be this one? This will be 0, and the y will be 3 by 4. So basically 3 by 4 over here. So your graph would be something like this, and I have it as well. I'll just show you. Okay, I'll just show you. So it won't be touching this at this point. Let me just erase this part. Yes. So lowest point is 3 by 4, which does not mean that, okay, my graph will touch over here. Okay, because this is the lowest point. I hope you're getting it. Okay, and if I just show you this graph, you'll see this is the exact graph I'm having. Okay, this is exactly, if you just see this carefully, let me just mark it up. Okay, so this is the point of minus 1 by 2. Okay, this was minus 1, and similarly this is the point of 3 by 4. Okay, this was what 1 by, I guess okay, yeah, this was 1 by 2, this was 3 by 4, and this is 1. Okay, I hope it must be clear. So minimize at minus 1 by 2, and height is 3 by 4, which I have just shown you. I hope this is clear. So everything is clear at this point. There is no saddle point because it has a proper minima over here. It's not a maxima, it's a minima point. Minima point at x equals minus 0.5. I hope the idea is clear. In detail, we have discussed this question. Okay, let's move on to the next question. Oh, again, very simple question we are having. Okay, so because we have a 3x3 real matrix, so I guess that we can have complex eigenvalues. We can still have complex eigenvalues, but determinant will always be real. Determinant will always be real. Okay, just remember that. If we have a real matrix, its determinant will always be real, but it still may have complex eigenvalues as it is present over here. And as my matrix was 3x3, so like, you can just tell me now what exactly is going to be your determinant over here. So I hope you know this. Whenever we have this kind of thing, we have studied it in the lower classes always. So whenever we find because how do we find eigenvalues? We find the eigenvalues through the root of some equation. Remember that? Through the root of some equation. And always remember, whenever there exists complex root, they always exist in pair. They always exist in pair. Okay, so that exists in conjugate pair. So if like, if z is 1 plus iota over here, let's say z1 is my first eigenvalue, and z2 is 2, then z3 is going to be nothing but z1's conjugate. Okay, if you have studied a bit of what your conjugate of z1, if you have studied a bit of complex number, then you know this. Okay, so as I mentioned, how do you get the eigenvalues? You find the roots of your characteristic equation. I hope you know that, remember that. Okay, and always root occurs or exist in, if complex roots occur or exist, they exist always in pairs. Okay, there exists always a conjugate pair for each of the complex root. So if this is 1 plus iota, then what should be the third root I must be having? That is going to be 1 minus iota. Okay, 1 minus iota. Now I know all the three eigenvalues. What is going to be the determinant? It is going to be 1 plus iota, 1 minus iota. Determinant is product of eigenvalues only into 2. What do I get over here? So this is 1 minus a square minus b square. And what is the iota's square? What is the iota's square? Okay, into 2. Okay, so this is 1 minus, this is also iota square is minus 1 into 2. So this is 1 plus 1, 2, 2 into 2, 4. So 4 is the determinant over here. 4 is the determinant over here. Very simple. Okay, I hope you have got this. So the questions are not really difficult. You just need to understand the basics and you will be able to find the answers very easily then. Okay. So let's talk about this question. This is again very simple. Okay, you just need to know the definitions. Let's see. So if I just tell you what exactly is a smooth function, okay, when we talk about this in calculus, so smooth basically represents to continuous function along with, you know, differentiability up to some order, differentiability up to some order, up to some order. What does that mean? Some order. So a smooth function ck, you know, a smooth function belongs to ck means it is continuous and it is k times differentiable. I hope you're getting this. K times differentiable. So a smooth function will be continuous, along with that it will be differentiable only also up to certain number. Okay, differentiable up to certain number. Now if a function belongs to a family of ck, which represents, you know, continuous function which are k times derivable or differentiable, then it's a smooth function of, you know, ck order, something like this. I hope it is clear now. So continuity or continuous function are just simple continuous functions are there. But when I talk about smoothness, then there exist extra constraints that they are differentiable up to some order as well. Okay. So what is the first point? A smooth twice differentiable function can have a global minima. Okay. So twice differentiable can have a global minima. Yes, we have already seen that example, 1 plus x square. Was it 2 times differentiable? Yes. First time differentiation was 2x plus 1 and second time differentiation was 2 only. Okay. So yes, a smooth twice differentiable function can have a global minima. Yes, that's true. All, this is important, all smooth twice differentiable function have a global minima? The answer is no. The answer is no. Okay. If you remember, we have seen a question in, you know, I guess video number 2, that we had some, you know, 1 plus 2x plus 3x square plus 4x cube, something like this, up to certain power was there. Okay. So if I just talk about this function only, x cube, is it twice differentiable? The answer is yes. Does it have a global minima? Just think about this. Does it have a global minima? The answer is no. The graph goes like this. Okay. It keeps on going in the lower direction. You won't be, you know, seeing any point which is the global minima, because if you tell me that, okay, let's suppose minus crore is the global minima, then it is going further than that also. It is going further than that as well. Okay. So all smooth twice differentiable function does not have global minima. Okay, does not necessarily have a global minima. We can have this simple example over here, x cube, x to the power 5. Basically, if I talk about in general term, any polynomial of order 3, okay, and in that case of degree 3 or degree odd, then in that case it really need not be then it doesn't need really have or need not necessarily have a global minima. Okay, I hope this is clear. So p is true but q is false. P is true, q is false. Very simple. Okay, let's move further. Again, a good problem over here. Okay, let's see. So I hope you have studied what is conditional you know, probability, and what is conditional PDF, probability density function. So let's see this problem. So we have, you know, joint distribution variables x and y, which is given like this. Okay, so how do we write? Actually, these has to be written like this. Okay, the exact way we must write it like this only, and this is x times of 1 plus 3y square as mentioned by 4, 0 otherwise, you know, and there is a range given which is 0 to 2 for x, and for y it's 0 to 1. Okay, so now I would like to find the conditional PDF, conditional probability density function. Basically what I'm looking for is f of x given y. And if I talk about the argument, something like this is something I'm looking for, and this is exactly equal to f of x y x comma y divide by f of y and then y. This is my conditional PDM. Okay, and how can I calculate it? Like this. Okay, so I know this is already given to me. This is already given to me. What about this? How do we find this? If you know marginal distribution, marginal density, that's what we are going to use. So marginal density is going to be, marginal probability density is going to be something like this. You just integrate your f of xy, okay, with respect to x. Okay, and what was the range for x? It was from 0 to 2. You just integrate your x within that range and you'll get marginal distribution or marginal density of y. Marginal density of y. What exactly is that? So we have integration of 0 to 2, what? X times 1 plus 3y square by 4 dx. Okay, so as you know, we are looking for x only, so whatever rest of the part is, that becomes constant for this integration. So what we'll have is 1 plus 3y square by 4, and integration will be x 0 to 2 and dx. What is this integration? This will be x square by 2, x square by 2, and the range is from 0 to 2. So what do we get? Okay, what do we get? This is going to be x square by 2 and the range is from 0 to 2. So let me just write so that you don't get confused. Plus 4 into 1 by 2 from x square by 2, and for x square I'll just do this 0 to 2, 0 to 2. So this, when I just put this 2 value and 0 value, what will I get? 4 minus 0, that will be 4, and 4 will get subtracted. So what I'll get at last? 1 plus 3y square by 2 only. This is going to be my this is going to be my marginal distribution or marginal density, marginal density over here for y. Okay, so now you can easily calculate this thing. It won't be a big issue, I guess. So you just need to divide x 1 plus 3y square, and the range has to be taken care of. Okay, what exactly is there in the denominator? It is going to be like this. It is 2. Okay, so over here there was 2, there was 2 square, so 2 square cut by 4, so we got 2 only in the denominator over here. So this 2, we get 2, this get cut completely. So what do we get? We get x by 2. So C is the final answer we are having. I hope this is clear. Okay, so I hope you enjoyed this video. Again, we have solved properly all our, we are solving. Okay, there are still more videos to come. Okay, so we'll be posting like 5 6 question within each video. So this is exactly our solution for these 5 questions or 6 questions, whatever I have solved right now. Okay, 4 5 6 whatever, and more question you'll be seeing in the next day's video. Okay, and do not worry, you'll be getting solution for each of the question before your GATE D exam. Okay, and you'll be having some time left as well. It won't be like, okay, on the last day only you are getting the final video. No, we won't be doing that. Okay, so it's like it takes time because we are also a bit busy, but I hope you will understand that we are giving proper detailed solution for each of the question over here. Okay, so if you haven't joined our group yet, do join. You can scan. Okay, do subscribe to our channel, and these are our channel, our Telegram group, our website. You can just go enroll for the operating system course. It is for free for GATE CS students who are targeting GATE 2025, and for GATE DA students who are looking for some test series, we have GATE DA Master Challenge. So tomorrow we are going to have our first exam for our first mock, which will be starting from 9:30 and it will continue till 6. Okay, you can log in and give the test, and post test you'll be able to get the solutions on our YouTube channel only. Okay, so I hope it is clear. Thank you for watching this video. I hope you have enjoyed this session. See you guys in the next video.